Good morning, everyone. Today we will be presenting our virtual reality fruit slash game developed for the MetaQuest 2 headset. Our goal was to create an immersive VR game where the player picks up a katana and slices fruits that are spawned in the environment. The game also contains a bomb mechanic that resets the score if the player slices it. We wanted the game to be simple, interactive, physically engaging, and fully compatible with VR controls. Throughout the development, we faced several technical challenges related to VR physics, object interactions, slicing effects, and Unity's XR system. And we will walk you through how we solved them. For this project, we used Unity 2022 LTS for creating the VR environment. Point 2. Meta XR Interaction Toolkit for VR hand tracking, grabbing, and collision. Point 3. Text Mesh Pro for in-game UI. Blender for experimenting with fruit slicing models. FFmpeg and video tools while testing game clips. C# scripting for all gameplay logic. And we tested everything using the MetaQuest 2 headset. Virtual reality development is challenging because everything interacts through physics and colliders in real 3D space. So, tools like rigid bodies, colliders, and interaction components were essential. Now that we have introduced the game and the tools we used, let me explain the full game concept in detail. Our goal was to combine two things: a simple idea that anyone can understand instantly, a proper VR experience that feels physically interactive. So we designed a system where fruits are spawned randomly in front of the player. They come from the left, right, and center, and they follow realistic physics arcs, which makes slicing unpredictable and fun. The player uses a katana that can be grabbed naturally using the VR controllers. When the player swings the katana, their real life motion is mapped directly into the virtual world. This makes the game feel physically satisfying. In VR, timing is crucial. Fruits need to appear quickly, enough to keep the game interesting, but not too fast that the player misses all of them. We experimented with different spawn timings until the flow felt smooth. We also wanted the game to be infinite. There is no level or round system. The challenge comes from the growing speed of fruits and the possibility of slicing bombs by mistake. One of the most time consuming phases of our project was solving the early technical issues. For example, the katana initially behaved very strangely. In VR, an object with a rigid body will react to forces from the environment, meaning if the physics settings aren't tuned perfectly, the katana can spin uncontrollably, drop out of the player's hand, jitter or vibrate, or even fly away. We spent hours testing different rigid body configurations like mass, drag, angular drag, gravity toggles, and collision models. Another problem was with fruit spawning. At first, fruit spawned behind us, above us, or even underground. We discovered this was caused by incorrect world transforms and scaling inherited from parent objects. We also struggled with mesh slicing. Our initial idea was to have fruits actually cut into two halves. We tried creating sliced fruit models in Blender manually and replacing them at runtime, but the process was inconsistent. Then we explored ES Slice, a mesh slicing library. However, due to Unity 6 API changes, the tool broke and produced stretched or invincible meshes. This forced us to abandon real slicing and focus on a more stable approach. At least twice our scene broke completely due to XR interactions being misconfigured. This forced us to start again from scratch. But these restarts also helped us understand VR object setup much more deeply. These early challenges shaped the direction of our project and helped us focus on making the game's core loop stable and fun. Before I hand it over, I want to expand a bit more on the challenges we faced in the early stages because they shaped the rest of the development process. One thing we quickly realized is that VR development forces you to think differently. In a normal game, if something spawns in the wrong place or a collider doesn't behave correctly, you can instantly see it on the screen. But in VR, you have to physically move, look around, and test everything inside the headset. Small mistakes like the wrong anchor point or an incorrect scale on a parent object cause the katana or fruits to behave in completely unexpected ways. Sometimes the sword would float away, sometimes fruits would spawn behind us, and sometimes nothing would spawn at all. These issues took time to trace because the problem wasn't always visible directly. Another unique challenge was that VR interactions are extremely sensitive to physics. A tiny change in rigid body mass or collider thickness can completely change how an object behaves when the player swings their arm quickly. For example, early in the project, the katana felt either too light or too heavy, and that made slicing feel unnatural. We learned that what looks correct in the Unity editor doesn't always translate correctly into VR. Because of this, we had to continuously test inside the headset, make adjustments, and test again. It was a slow process, but it helped us understand VR physics much more deeply. These early problems also taught us the importance of keeping our project organized, at least twice. We restarted from scratch because old settings or broken prefabs affected new features. Even though it was frustrating, those restarts actually helped us build cleaner hierarchies, better object structures, and more stable interactions the next time. All these initial lessons became the foundation of our project and they made the later stages like fruit spawning, slicing, feedback, and gameplay balance much easier to implement. With that, now hand it over to person 2 who will explain how we develop the main gameplay mechanics and how everything comes together during the actual slicing experience.
Hi, I'm Nikhil, and I'll continue from here by explaining how we implemented the main mechanics of our VR Flute Slash game. This was the most important part of the project because it determines how the game actually feels to play inside the headset. So, we began with the fruit spawning system. Even though fruit spawning sounds simple, in VR it becomes a very delicate balance. We created three different spawners, one on the left, one on the right, and one in the center. And each of them launches fruits upward with a random force, a random angle, and a bit of rotational motion. This randomness is essential because it keeps the player constantly adjusting and reacting, which is what makes the slicing feel dynamic. We spent a lot of time adjusting the exact values. For example, if fruit spawned too slowly, the game felt empty. If they spawned too quickly, the player got overwhelmed. If the arcs were too low, slicing became too easy. If they were too high, the fruits went out of reach. Through repeated testing inside the headset, it took us a lot of time. We tuned the timing and motion so that each fruit feels satisfying to slice. Next, we focused on the katana interaction. This turned out to be much more difficult than we expected. The katana had to feel stable in the player's hand, no matter how fast they swung it. In VR, the player's arm speed can be extremely fast, and Unity's physics engine has to keep up. We experimented with different rigid body settings like mass, drag, interpolation, and gravity behavior. We also tested different types of colliders to make sure the katana blade would consistently detect this. At one point, the katana would start spinning on its own. It started vibrating. It started rotating in the air, and at most of the moments, it didn't even attach to the controller because we were actually using a grabbing technique. Uh, but once we found a good balance, the katana felt good, so we kept it. After that, we added the slicing feedback. Slicing shouldn't just be a collision. It shouldn't be something like uh, we touched it and it just destroys unnaturally. It needs to feel like something meaningful happened. So when the katana touches a fruit, the fruit instantly disappears, a particle burst appears, and a slicing sound effect plays. These three components together make the slicing feel crisp, fast, and rewarding. Even though we've tried different other alternatives, we tried using the blender to cut the fruit prefabs into two, and once if collision is detected, I mean the slice is detected, the fruit gets deleted, and from there naturally the two cut halves of the fruit would fall down. But the meta, the Unity 6, the meta and all didn't support us. We faced like a lot of errors. We spent at least like 5 hours on the blender, but it didn't work out for us. We also tried the easy slice library, which was available in Git, but that too didn't give us results. So we had to do with the destruction and particle effects. To add challenge, we introduced the bomb. The bomb behaves just like a fruit in the air, but slicing it resets the score. This forces the player to focus and choose their swings carefully instead of slicing everything blindly. We had to make sure bombs appeared occasionally but not too frequently, otherwise, the game would feel frustrating. This balance was reached after multiple rounds of playtesting. Another important part of VR development is UI placement. Our score display is not on a flat screen, it's a floating panel inside the world. We tried several positions near the katana, close to the player's face, and even above the spawners. Initially, it didn't even show up in the quest. It showed up in the game scene, but once we build and run it on the meta quest, it can feel, and getting that feel correct requires many tiny adjustments. For example, we had to test how far fruit should appear from the player. Too close and it feels uncomfortable. Too far and the player has to overreach. We also tested different blade size to make slicing accurate without making it too easy. There were times when slicing wasn't registering properly because the player's arm was moving faster than Unity's physics updates. Fixing this required expanding the blade collider slightly and adjusting smoothing settings. We also spent time making sure the slicing pace felt right, not too slow, not too fast. This required many rounds of testing, watching how players reacted, and adjusting values one at a time. Every small tweak improved the experience. All of this refinement is what finally made the game feel at least a bit playable, though we responsive and enjoyable inside the headset. Even though it isn't the best game, but given the time constraints, we've learned a lot about VR game development, and how it actually works. Maybe in our next project, we can do an even better game. With that, I'll now hand it over to person 3 who will go deeper into the advanced challenges we faced during development, the issues with VR physics and slicing tools, and the improvements we plan to add in the future.
Hello, my name is Shashank, and I'll continue from here by going deeper into the technical challenges we faced during the development, the solutions we discovered, and the improvements we want to implement in future versions of the game. When we decided to create this VR fruit slash experience, we expected some difficulties, but we didn't realize just how many things would break along the way. VR development is very different from normal game development. Everything is interactive, everything depends on physics, and everything has to feel natural to the player. Even small mistakes can completely ruin the user experience. One of the biggest challenges we faced early on was regarding realistic fruit slicing. Our original vision was that when the player sliced a fruit, it would break into two halves, which would fall naturally under gravity. We thought we could simply model sliced fruits in Blender and replace them when a slice occurs. But we quickly found that this approach wasn't practical. The slice lines didn't always match the angle of the katana. The pivot points of the sliced halves were often misaligned, and getting the physics to behave properly became a challenge on its own. So, we explored automated slicing. We tried using mesh slicing libraries, which are supposed to cut objects in real time according to the blade's direction, but the tools we tried were not compatible with Unity 6. Some slices created broken meshes, some removed textures entirely, and some caused the object to disappear. We spent a significant amount of time testing these tools, but eventually we had to accept that real time slicing wasn't stable enough for our project. That's when we shifted to particle based slicing effects. While not a true slice, the effect is visually satisfying and avoids all the technical complications. Another major problem area was VR physics. The katana, for example, caused us endless trouble. In a normal game, you can control everything with animations, but in VR, the player directly controls the object. This means that if the physics aren't configured correctly, the katana can behave unpredictably. At one point, the sword would spin in circles the moment we grabbed it. At another point, it would drift directly upwards on its own, as if it had a life of its own. These issues came from incorrect rigid body values, wrong parent child hierarchies, and misconfigured interaction components. We had to constantly experiment with mass, drag, gravity, settings, and interpolation before the katana felt stable and responsive. Fruit spawning also gave us many unexpected issues. Fruits would spawn at the wrong height or behind the player, or sometimes too far away from each other. Sometimes the fruits would be affected by forces coming from the other objects in the scene. And in some earlier attempts, fruits kept floating upwards into the sky because we forgot to set gravity or applied the wrong direction of force. Debugging VR spawning is challenging because you must repeatedly put on the headset, see where the fruit appears, adjust the position, remove the headset, and repeat the cycle many times. But this process taught us how important world space alignment is in VR. Another interesting challenge was optimizing performance. VR is extremely sensitive to low frame rates. Even dropping a few frames can cause motion sickness for the player, so we had to ensure that our game stayed smooth at all times. This meant limiting unnecessary physics interactions, reducing the number of active particles, and ensuring that no hidden objects were consuming processing power. We also optimized the colliders and removed any components that were not necessary. Unity 6 brought its own set of issues. Several tutorials and tools online were built for older versions of Unity, and many of them did not work in our environment. Some shaders broke, some VR interactions stopped working after packages updates, and at one point our entire XR setup became corrupted. We had to restart the project from scratch more than once because fixing certain bugs was harder than rebuilding from a clean setup. Even though this felt frustrating at the time, these restarts helped us understand VR development more thoroughly and prevented us from depending too much on external tools. Another unique challenge was debugging on the Quest 2. When testing on a PC monitor, the Unity console instantly shows errors, but when testing in VR, we can't see logs or messages unless we set up special debug tools. To work around this, we had to add on screen messages inside the VR environment simply so we could see whether collisions were being detected or whether certain interactions were firing correctly. This was time consuming but necessary as many VR issues do not appear on the monitor view. Even though the current versions works well, we have several ideas for future improvements. One major improvement would be implementing real fruit slicing. With more stable mesh tools or better support in future Unity versions, we could allow fruits to actually break into two halves. Another improvement would be adding combo scoring. For scoring, slicing multiple fruits within one swing could give bonus points. We also want to add sword trails, glowing lines that appear behind the katana when swung fast to make the slicing more dynamic. We also want to introduce haptic feedback so the VR controllers vibrate slightly when the fruit is sliced. Another idea is to add different types of fruits, each with unique behavior. Some may explode, some may fall faster, some may give bonus points. We also consider adding difficulty levels, power-ups, and even a proper start menu inside the VR. To conclude, uh, this project was a major learning experience for us. It pushed us to understand VR physics, motion design, perform optimization, and interaction system at a much deeper level. We encountered problems we didn't even expect. We restarted from scratch more than once, and we spent hours testing inside the headset, but each challenge helped us learn something valuable. Today, we have a complete VR game that feels smooth, stable, and enjoyable to play. And most importantly, we now have a strong foundation for building more advanced VR experiences in the future. Thank you.
Good morning, everyone. Today we will be presenting our virtual reality fruit slash game developed for the MetaQuest 2 headset. Our goal was to create an immersive VR game where the player picks up a katana and slices fruits that are spawned in the environment. The game also contains a bomb mechanic that resets the score if the player slices it. We wanted the game to be simple, interactive, physically engaging, and fully compatible with VR controls. Throughout the development, we faced several technical challenges related to VR physics, object interactions, slicing